Right, so yesterday we talked about rationalizing the denominator. When we rationalize the denominator, we get rid of the square root. So we can't get rid of the square root from the whole problem. We are just really moving it. But in order to move it, that's how we rationalize. So in B, the difference between B and then A, what we did yesterday, A, we just had a square root. For B, we have a cubed root. How many of a kind do we need when we have a cubed root? 3. We need 3 of a kind. So I need 2 more cubed root of 5. So I'm going to multiply by the cubed root of 5 and another cubed root of 5. And whatever I multiply to the bottom, I also have to multiply to the top. So the top's going to get a cubed root of 5 and a cubed root of 5. Yes? Yeah. So then on the bottom, we can combine these together. We have the cubed root of 5 times 5 times 5. We said that we circle 3 of a kind. So what would this simplify to? What comes to the outside? 5. Awesome. So this simplifies to just 5 in our denominator. Now on top, we can't multiply the 2 with the cubed root of 5s, but we can combine the cubed root of 5s together. This would be the cubed root of 5 times 5, which would be the cubed root of what? 25. Awesome. So we have 2 times the cubed root of 25 up top. So that would be our answer. We just rationalized the denominator. We got rid of the radical from the denominator. Right, now example 14 is a little bit different. Here it tells us to rationalize the numerator. Typically we rationalize the denominator because we don't like square roots in our denominator. But this one, the question is just asking us to do it for the numerator. So it's the same steps, it's just up top now. Now, we have 2 terms up top, so we can't just multiply by what's missing because these 2 terms are being subtracted. We have that minus sign in the middle. So what we need to do is multiply by the conjugate. Now the conjugate just changes the sign in the middle. If I had 2 plus square root 3, the conjugate of this would be 2 minus square root 3. So conjugates are the same thing, just the signs in the middle flip. So for square root of 5 minus square root 7, the conjugate would be what? So it's the same thing, but the sign in the middle flips. So what would our conjugate be?
Square root of 5 plus square root of 7.
Awesome. Square root of 5 plus square root 7. And then whatever we multiply to the top, we also have to multiply to the bottom too. So the bottom gets a square root of 5. Gets multiplied by the square root of 5 plus the square root of 7. So now let's simplify the top first. We're multiplying these 2 things together. Since they each have 2 terms, we have to FOIL them. So to FOIL, we're going to start by multiplying the first. What is the square root of 5 times the square root of 5? 5. Awesome. Then the outsides would be the square root of 5 times the square root of 7. What's the square root of 5 times the square root of 7? Awesome, square root 35. Then the insides would be the negative square root 7 times square root 5. What would that be? Negative square root 7 times square root 5. Negative square root 35, perfect. And then the last would be negative square root 7 times square root 7. What would that be? So it's negative, but what's square root 7 times square root 7? 7, perfect. Now let's combine our like terms to simplify. 5 minus 7 would be what? Negative 2. And then what is square root 35 minus square root 35? What do we think? 0. They cancel out. So we're just left with negative 2 up top. Now on the bottom, we have 2 times square root 5 plus square root 7. Here we don't have to FOIL. Since it's just one term, we could just distribute. So we have 2 times square root 5 plus 2 times square root 7. Now there's one more step we can do to simplify. Since all 3 of our whole numbers have a factor in common, we can divide by that factor. So I can divide all 3 of these terms by 2. So I'm going to divide by 2, divide by 2, and divide by 2. So then up top we have negative 1 over square root 5 plus square root 7. All right, next we're going to talk about simplifying exponents and rational exponents, so exponents that are fractions. If we have an exponent that's a fraction, we can simplify it. The top number, our numerator, stays as an exponent. The denominator is an index. So if I had something like x to the power of 5 over 4, I could simplify this by making the 4 the index on my radical. So this would be the same thing as saying the 4th root of x to the 5th power, which we talked about yesterday, that we could also put that exponent on the inside. So we could have the 4th root of x to the 5th power. So all 3 of these are the same thing. So looking at A, we kind of talked about this a little bit yesterday. If we have a negative exponent, it flips the number. So to make it positive, we're going to put that number in the denominator of a fraction. So now it's still negative 32, but the sign changes for the exponent. So now it's positive 4 over 5. And the exponent turns positive. So when you move it, it turns positive. Now we can simplify this a little bit more. The number up top is our exponent. The number in the denominator is the index. So our denominator is going to go out front. We now have 1 over the 5th root of negative 32 to the 4th power. Now let's see if we can simplify the 5th root of negative 32. Can I take the 5th root of a negative number? Yeah, we can. We talked about that yesterday too. If it's an odd index, it's okay. Odd is okay that we can take the 5th root of a negative. So since 5 is negative, we can do that. That just tells us that our answer, though, is going to be negative. Whatever we get in the denominator, whatever comes out will be negative. Let's see if we can break this down. What are 2 factors of 32? What are 2 factors of 32? 8 and 4, perfect. 2 factors of 8? 4 and 2. And 2 factors of 4? 2 and 2. How many of a kind do we need? 5 of a kind. Do we have 5 of a kind? Yes. So it's going to come out. Negative 2. Perfect. We said that it was going to be negative since we had that negative on the inside. And 2 comes to the outside. So it'd be negative 2. But we still have that exponent to the 4th power. And it's still in our denominator. So our last step, let's find what negative 2 to the 4th power is. So let's write it out. -2 times -2 times -2 times -2. What's -2 times -2? 4. And then -2 times -2? 4. 4 times 4? 16. Awesome. So this would be 1 over 16. So with negative exponents, let's say we had x to the power of -2 over y to the power of -3. So I made this up, but it's going to help you with the homework. You've got a few questions like this in the homework. If you have a negative exponent, you want to move it to make it positive. So if it's on the top, we're going to move it to the bottom to make it positive. If it's on the bottom, we move it to the top to make it positive. So to make the x to the power of -2 positive, it's going to move to the bottom and turn to be a positive exponent. So when you move it, the exponent changes signs. For the y to the power of -3, we're going to move it to the top, and when we move it, the exponent becomes positive. For b, it's super similar to the first question that we had from the notes yesterday. We don't have any exponents on the outside, so we don't have to worry about distributing or anything. We can just combine the like terms. So let's multiply our like terms. We have -5 times 3, which would be what? -15. Perfect. And then since the x's, the bases are the same, when we multiply, what do we do to combine the exponents?
You add them.
Add them. So when you're multiplying, you add the exponents. So here we have x to the power of 5 over 3 plus -3 over 4. Careful. What do we need? What do we need to have when we're adding fractions? A common denominator. So we can't just add straight across. If we're multiplying fractions, you multiply straight across. When we're adding, we need a common denominator. So what would our common denominator be here? 12. What do we need to multiply by the first fraction to get 12? 4. So we have 20 over 12. And then what about the second fraction? What do we multiply here? 3. So this would be -9 over 12. So then we can just subtract our numerators. What's 20 minus 9? 11 over 12. So we get x to the power of 11 over 12. So this would be our answer. Any questions here? Let's look at C on the next page. So for C, we have the 9th root of a to the 3rd power. Now, how many a's do we have on the inside? 3. How many do we need in order to circle and take out? 9. So we definitely don't have enough to circle and take out, so we can't simplify it that way. But let's see if we can change this to write it all as an exponent and see if we can simplify it that way. So what would be, in my exponent, what's the numerator? 3 or 9? What would our numerator be? What goes up top? 3. The exponent goes up top. The index goes on the bottom. So we have a to the power of 3 over 9. Can I simplify 3 over 9? So we have a to what power? 1/3. Awesome. And then for D, here when we have a radical inside of a radical, it's just like having a power raised to power. You multiply the indexes together. The one on the inside, though, doesn't have an index. What is it implied that that index is? A 2. So when we multiply our indexes together, what's our new index going to be? 6. We have the 6th root of 125. Let's see if we can break this down. What are 2 factors of 125? 5 and 25. What are 2 factors of 25? 5 and 5. Can we break it down any more? How many of a kind do I need in order to circle? 6 of a kind. Do I have 6? Can I simplify this? No. So this is as simplified as we can go. So same thing when we have a power raised to a power. If you have a square root inside of a square root, you just multiply the indexes together.